discuss about curvilinear regression. Also, this one is a nonlinear regression. So, nonlinear regression. So, nonlinear regression. Nonlinear regression. Regression. So, nonlinear regression means if we draw the scatter diagram of this one, then this one is not a linear. Means like this one. In a previous lecture also we discussed like this one. These are the points. These are the scatter diagram. Nonlinear regression between what? Xi, yi. I ranges from what? 1 to n. So these are the bivariate distribution. Means there is a n data. If we plot these n data, point representation of this one. So this one is not a look like is a linear, means a straight line. So what is the regression? Regression is an average relationship. So average relationship here, if we talk about this one, then this one is an average relationship. Average relationship means some point lie on this curve and some point does not lie on this curve. If some point does not lie on this curve, then by the method of a principle of least square, we minimize this error. And find the what? Find the normal equation as usual. In a previous in a lecture of a method of a principle of a least square, we discuss about this one. How we find the two equations. How we find the normal equation. We find the error, then we find the square of error, then we find the sum of a square of error. Then we write down what? Then we write down the normal equations. So here I am not going to describe what is the principle of a least square. Directly here we use the principle of a least square to find out a normal equation. So what is the value for s? S is a what? S is a summation of a ei square. Ei is a what? Here suppose here we are going to describe three type of equations. First one, we are going to find out nonlinear regression in form of a what? A plus bx plus cx square. Second one, if a y is a what? In the form of a b to power x. Third one, this one is a small y. If we write a small y here. Small x and small y. So y equal ab to power x and y equal a into x to power or y equal a into e to power bx. So either in this form, this one is the first one, this one is the second one, this one is the third one, and this one is the fourth one. So this one is also a part of how we fit the curve by the method of a principle of a least square in these form. These are exponential curve, this one is a power curve, and this one is a what? Non-linear in terms of polynomial of degree 2, or similarly polynomial of degree 3, or whatever the degree of a polynomial. So we are going to one by one try to describe these values. So this one is a y, and this one is also a y, and y. So one by one, by the method of principle of a least square. So if we write the first one, first curve means these are the given xi, yi with the given. So first curve is a what? Y equal a plus bx plus cx square. Means regression curve is in a form of a parabola. Then we find what? We find corresponding to each value for I and I equal 1 to n. This one there is a yi equal a plus bxi plus cxi square. Means this one is a representation of this curve. Means if we put x1, y1, then y1 equal a plus bx1 plus cx1 square. So if this one lie on this curve, this parabola, then the difference, then error becomes 0. If this one does not lie on a parabola, on this curve, if this one does not lie on this curve, then there is a difference, and that difference is measured by the what? EI. EI become what? YI minus A plus BXI plus CXI square. So this one is a. So since this may be positive or negative, then maybe one error neutralizes the other error. So here we find the what? Square of this one. EI square. EI square become what? YI minus A minus BXI minus CXI square. Then we find what? Then we find the sum of these ones, S equals summation of I equal 1 to n EI square. EI square. Then we find the what? How we find the normal equation? Here we put the del S upon del A equal to 0. These are the necessary conditions for the minima or maxima. Del S upon del B equal to 0 and del S upon del C equal to what? 0. So after simplification of these three equations, what are the normal equation? Normal equation become what? As we described in a earlier lecture by the method of a principle of a least square, del S upon del A, we find the partial derivative with respect to A, with respect to B and with respect to C. Then we simplify. Then what are the normal equation? Normal equation become what? Normal equation become summation of a yi equal what? Summation of a yi equal na plus b summation of a xi plus c summation of a xi square. And second one is a summation of a xi yi equal a summation of a xi plus b summation of a xi square plus c summation of a xi cube. And third one, summation of a xi square yi equal a summation of a xi square summation of a xi square plus b summation of a xi cube plus c summation of a xi to power 4. So xi yi be the given, then we find what? Summation of a yi, summation of a xi, summation of a xi square, means so all the coefficient of a, b and c. Once we find all the coefficient of a, b and c, then this becomes a system of a linear equation with 3 unknown and 3 equation. After solving 3 unknown and 3 equation, we find the value of what? We find the value of a, b and c. Once we find the value of a, b and c, then we put the value of a, b and c here in this equation. Then we find the desired form of a what? A plus bx plus cx square. So desired form of a nonlinear regression equation. Also this one is a curve fitting of a polynomial of a degree 2. So you may treat it as this one is a curve fitting by the method of a least square of a polynomial of a degree 2. So this one is a way how we find the nonlinear regression line if regression not a line, nonlinear regression curve if this one is a polynomial of degree 2. So how we write the normal equation? This one is very simple, multiplied by the summation of this one and then coefficient of a multiplied by the coefficient of a, then we find the first normal equation, multiplied by the coefficient of a b, then we find the second normal equation, multiplied by the coefficient of a c, then we find the third normal equation. So this one is a what? This one is a, if the curve is in form of a parabola, and this one in a detail we discussed about, already discussed in a previous lecture, in a lecture of a principle of a least square. So you may refer this one for detailed study, the lecture of a principle of a least square. Second one, second form is a what? Y equal ab to power x. So how we solve such type of a problems? Means y equal ab to power x. So after taking the log, this one converted into a linear regression. So how we solve this one? What will happen? Taking the log on both sides. So log, natural log y equal, taking the log and using the property of a log, log base 10, ab to power x, this become of log base 10 y equal what? Log base 10 a using the property of a log plus x log b. So here we assume that this one is a what? This one is a capital Y and this one is a what? Capital A. This one is a small x plus capital B. What is the capital B? This one is a capital B. This one is a capital B. This one is a what? This one is a capital A. This one is a capital A. This one is a what? This one is a capital Y. Y equal A plus Bx. So now this one become a what? This one become a linear equation. Equation of a straight line y equal A plus xb. This one is a capital Y and capital Y is a log of a y base 10 and capital B is a log of a b base 10 and A is a log of a base 10 log of a A. So what is the normal equation? We know that what is the normal equation of this 2 we know that the normal equation become what? Summation of yi, capital Yi equal n capital A plus b summation of xi. And second normal equation becomes summation of x, small x, capital Yi equal A summation of xi plus b summation of xi square, summation of xi square. So this one is a what? This one is a simultaneous equation, means with two unknown a, b, a, b. We find the value for, if we have value for y, then we find the summation of capital Y, summation of small xi, summation of small xi and capital Y, summation of xi, summation of xi square. Then after solving this system of a linear equation, we find the value for a and we find the value for b. And we know that once we find the value for a and b, what is the value for a? A equal log base 10 a. Then what is the value for a? A become 10 to power a. And b equal what? B equal log base 10 b. This implies that what is the value for b? B equal 10 to power p. So what is the meaning of this one? We take the anti-log of this one. We take the anti-log of capital A, anti-log of capital B, or you may write this one equal anti-log of A and B equal what? Anti-log of capital B. So once we find the value for A and B, putting the value for A and B, small a and b here, then we find the required form of a nonlinear regression. So in a similar manner, we convert the next two with the y into a into x to power b, y into a into e to power bx, also in a form of a linear equation. How we solve this one? Means how we convert this one is a very easy process like this one. In a similar manner, we are able to convert this one into a linear regression. Once we convert into a linear regression, then we write normal equation of a linear equation. Then we find the value of a capital A, capital B. Then we find the anti-log. Then we find the small a and small b. So this one is a process. So how we write the second one? This one is not a second one. This one is a second one, and this one is a third one. Y equal ax to power b, ax to power b. Again taking log on both sides. Taking log on both sides, then this become what? Log base 10 y equal log a plus v log what? Log x. If we take the base 10, then this one is a what? This one is a capital Y, this one is a capital A, and this one is a capital X. Then what is the equation become? Y equal a plus b capital X. So what is the normal equation? Now normal equation become what? Again, how we write the normal equation? Summation of capital Yi equal n capital A plus b summation of capital Xi, and second one summation Xi yi equal a summation of Xi plus b summation of Xi square. So after solving this one, we find what? We find the capital A, we find the value for capital A, and we find the value for small b. After solving this one. So after solving this one, how we find the A and B? A equal what? Antilog of A, and B is a what? B. Once we find the A and B, then putting here, then we find the required form of a nonlinear regression, as well as this one is a curve fitting in this form. So you may also treat this lecture as an extension of a curve fitting by the method of a principle of a least square in case of a nonlinear equation. Now third one. Third means a fourth one, not a third one. Fourth one, if we write what? Y equals a into e to power bx. Now taking a log both sides, taking log on both sides, this become what? Log of y equals log of a plus what? bx log of base and e. So here we consider this one is a capital Y, this one is a capital A, and this one means this one is treated as a what? This one is a capital B. Means a B is a what? B log base 10 E. This one is a. So Y equal what? Y equal A plus capital B X. So again we write what? Again we write a normal equation of this one. Normal equation of this one is a yi equal n capital A plus b summation of xi, and second one is a summation of xi yi equal a summation of xi plus b summation of xi square. Then after solving this system of a linear equation, we find the value of a and b. A equal what? A and b. Then how we find the small a? Small a is a antilog of a capital A, and small b is a what? Capital B is a capital B equal b log base 10 E. Then what is the value for b? B equal capital B upon log base 10 E. So this one is a what? These are the procedure if the curve in this form or this form or this form. These are the nonlinear regression as well as the curve fitting by the principle of a least square. So here there is a need to means notice these are the capital Y. Capital Y is a once we take the log of y small y, then we find the capital Y. Once we take the log of y small x given data, then we find the capital X. So once we write capital Y and capital X, then we write a normal equation. Once we write a normal equation, then we find the capital A, small b, capital B. Then taking the antilog, then we find a what? Then we find a actual value of A and B, small a, small b, and whatever the values is required. So now we are going to solve one numerical problem, not to because the procedure of all three methods are same. So only we solve one numerical problem. One numerical problem is y equal ab to power x. Y equal ab to power x. Then we finish this lecture means what? Not y equal ab to power x. We try to solve y equal ax to power b. And similarly, we able to solve this one and this one also. And as in a starting, we say that this one is also extension of a curve fitting of by the method of principle of a least square in case of a curve is not a linear, curve is a non-linear. So here now we are going to solve this one means one numerical example in the form of this one. So okay, now we solve another numerical example based on a curvilinear regression as well as nonlinear curve fitting. Curve fitting in form of exponential curve, curve fitting in form of a power of x. So here we are going to solve, means fit a curve of the form of a y equal a into b to power x, means a nonlinear regression in the form of a y equal a into b to power x. And also you may say this one is a fitting of a curve in the form of a y equal a into b to power x. In the following data, x and y is a given. X and y is a given. Then obviously how we find the solution? We able to find out the solution of this one, means first we write a what? First we write a normal equation, means in this form, means first we write this one y equal what? We start from the solution here, y equal a into b to power x. So we take the log of both sides, taking log on both sides, log on both sides. So what is the value? Log y equal, if we take the base 10, log base 10 a plus x, b log x, not here, x log b, x log b, x log base 10b. So here we assume that this one is a what? Capital Y equal capital A plus x capital B, means if here we write capital Y equal what? Log base 10 small y, and capital A equal what? Log base 10 capital small a, and capital B equal log base 10 small b. This one is what? This one is the value of this one. So as this one is a what? Look like as a linear regression, means a line of regression y equal a plus bx. So what is the normal equation? Normal equation are what? Normal equation become what? Normal equation become summation of a capital Y I equal n a plus b summation of a xi, and summation of a small xi capital Yi equal a summation of a small xi plus capital B summation of a xi square. So what is the need here to calculate capital Yi? Capital Yi means we take the log of a small yi, take the log of this one, then we find the sum of this one, sum of a log of a y, then this become what? Capital of us, summation of a capital Yi. Similarly, we multiply x and taking the log of this one. So there is a need of a calculation of a log, so manually you cannot calculate this one. So there is a need of a calculator. So already we calculated the value of means write down the log of this one, log of this one, log of this one, and log of this one in a tabular form, and here we noted down the values of this one, means this one is the value for x is a what? 1, 2, 3, 4, 5 and 6. And what is the value for y is this one, 1, 5, 100, 61, 50, 28. We take the log of this one. Log of this one, log 151 is about 2.179. And we know that what is the value of a log 100? Log 100 is a 2. Log 61 is a 1.785. Log 50 is a 1.699. Log 20 is a 1.3010. Log 8 is a 0.9031. And what is the x square? 1. And this become what? This become 2. Square of a 2 is a 4. Square of a 3 is a 9. Square of a 4 is a 16. Square of a 5 is a 25. Square of a 6 is a 36. So 36. What is the next to calculate? Next to, there is a need to summation of a xi, then we find the summation of a xi. Summation of a xi yi. So we multiply this one, small x small x and capital Y. 1 multiplied by 2.179, this becomes 2.179. 2 to the 4. 3 multiplied by 1.785, this becomes 5.3559. Similarly, 6 multiplied by 0.9031, then we find 5.4186. So if we find the sum of these terms, these columns, we find the sum of these columns, sum of these columns, we write here in this form. This one is the tabular form. So this one is the data. Now if you find the sum of this one, sum of this table, then this one is the what? This one is the sum. This one is the sum. This one is the sum. So if you find the summation of xi is a 2 plus 1, 3, 3, 6 plus 4, 10, 15, 15 plus 6, 21. Similarly, we find the sum of this one is about 9.8671 and 4, 1, 5, 5, 9, 5, 14, 14, 16, 16 is 30, 30, 25, this one become 55, 55 and 36, this become 91. And similarly, we find the sum of this one is a 30.2545. Now we put the values of these summation of xi, summation of yi, capital yi, summation of xi square, summation of small x, capital Y in the normal equation. So if we put these values in a normal equations, so what is the normal equation? Normal equation is a what? Summation of yi. Summation of yi. So once again, if we write the normal equation and putting the values, then what is the value? This one is a what? Summation of yi. Summation of yi equal na plus, sorry, not a na small, not a small, this one is capital A plus b summation of a small xi. And second one is the summation of a small x, capital yi equal a summation of a small xi plus b summation of a xi square. So just we put the value of summation of a yi. Summation of a yi is a 9.8671 equal n. How many number of terms? 1, 2, 3, 4, 5, 6 terms. 6 capital A plus b. If you write b here, summation of a xi. Summation of a xi is a small xi. This one is a 21b. 21b. Now second equation becomes summation of a small xi and capital yi. Summation of a small xi and capital yi. This one is a small x and capital Y. There is a need to note it down. This one is not a small x and a small yi. Now in a normal equation, this one becomes small xi and capital yi. Capital yi is what? Capital yi is the log of a small yi. So what is the sum of this one? 30.2545 equal what? A. We write a summation of a xi. Summation of a xi become 21. 21 plus b summation of a xi square. Summation of a xi square is what? 91. 91. So this one is a what? This one is a system of a linear equation. If we solve this system of a linear equation, then what is the value for a and b? Here we noted down the value for a and b. The value for a become 2.5010 minus 0.2447. So how we find the value for small a and small b? What is our aim? Our aim is to find out a small a and small b. So taking anti-log. So a equal what? A equal log of base 10 a. So what is the value of a? A equal anti-log of a capital A. This one equal 10 to power a. So what is the value for a? Now a become what? A become anti-log of 2.5010. This is very simple. With the help of a calculator, you may find the value for 2.5010. What is the value for this one? This one become what? 316.95. This one become what? 316.95 316.9568. Similarly, what is the value for B? Capital B is what? Log of 10 small b. So what is the value for this one? Value for this one become minus of, then this implies that what is the value for B? Anti-log of B, this one 10 to power B, and what is the value for B? B become anti-log of what? Anti-log of minus 0.2447. So we noted down the value for this one also. The value for this one is 0.5962. 0.5962. What is the value for this one? The value of this becomes 0.5962. This one is the value for B. So what is the form of equation? Now we find the value for what? Small a and small b. Once we find the value for small a and small b, this become what? Y equal a is what? If we write y equal a into b to power x, a is what? A become 316 a into b to power x. This become what? A is a 316.9568 into b. B is a what? 0.5962 to power what? X. So this one is the required form. This one is the what? This one is the required form. This one is answer. This one is answer. This one is answer. This one is the required form. So what is the summary of nonlinear regression? Whatever the regression is, whatever the form of a regression is required, means either y equal a plus bx plus cx square, or y equal a plus bx plus cx square x cube, means whatever the degree of a polynomial. If we generalize this one, then y equal a0 plus a1x plus a2x square plus a3x cube up to an into x to power n. Then we write a normal equation by the method of a principle of a least square. So there is no need to derive the normal equation in all the cases. How we write the normal equation? This one is a thumb rule, means we write yi equal a0 plus a1xi plus a2xi square up to an xi to power n. Then take the summation on both sides, then multiplied by the coefficient of a0. This one give the value of this one give the first normal equation. Then multiplied by the coefficient of a1. This one give the second normal equation. Similarly, multiplied by the coefficient of an. Then this one give the nth normal equation. Once we find the normal equation, then from the given data, means xi, yi is a given for I equal 1 to n, means x1, y1, x2, y2 up to xn, yn is given. Then according to the requirement, we find the value of summation of xi, summation of yi, summation of xi, yi, summation of xi square yi. Whatever the data is required, we calculate in a tabular form. Then we put these values in a normal equation. Once we put these values in a normal equation, then this will become a system of linear equation. We solve the system of linear equation, then we find the value of a, b, c, or a0, a1, a2 up to an. This one is a way if there is a polynomial of a degree n, means we try to fit a polynomial of a degree n. If this one is in form of an exponential curve, if this one is in form of a power curve, means in form of a y equal a into b to power x, y equal a into x to power b, y equal a into e to power bx, or any other form. So if we take the log of log on both sides, then these form, if converted into a linear regression, linear line. Why this one is a linear line? Means a line is a linear. So this one is a linear regression. Linear regression. This one converted into a regression line. So once this one converted into a regression line, then we write a normal equation in form of a regression line, means a two normal equation. Then we find the values of a capital A, capital B, capital A and capital B according to the what? According to the values of according to the nature of a curve. This may be log base 10A, then log base 10B. This one is the value of capital A and capital B. Then we take the anti-log of this one, then we find the value of a small a and small b. Once we find the value of a small a and small b, we put these values in a required form of a curve, then we find the desired form of a curve. This one is all about this lecture. Thank you for watching my video.